The hyperbolas definitely have the most stuff going on. For each graph, we need to find the center, vertices, asymptotes, and foci, and we're also going to need a box to help us along the way. So first, let's start with the center. Just like before, the center is going to come from the x and the y, and since nothing's being added to x and nothing's being added to y, our center is going to be at the origin, 0, 0. So I'll plot that and label it with a little c. Next, to find the vertices, that's going to come from the first fraction. And since this fraction is x squared over 9, that means we're going to go square root of 9, or 3, units in the x direction. So 1, 2, 3, and 1, 2, 3. This is where my two vertices are going to be. So those two vertices are at plus or minus 3, 0. Now we're going to make that box. And we're going to do that by using the second fraction, the y. And we're going to go square root of 1, or 1 unit in the x, or in the y direction. So we're going to go up and down 1. And this will give us the boundaries of our box. We need this box because it's the diagonals of this box that will give us our asymptotes. So I'm going to draw them in real quick and label them. So because both of these asymptotes go through the center, I'm going to use the point slope form for the equation of the line, and that is y minus the y coordinate of the center, which is 0, is equal to the slope times x minus the x coordinate, again 0. Now when we look at these slopes, we think about rise over run, and from the center I'm going to rise 1 and run 3 to find the slope of this first line. That means its slope will be 1/3. For the negative one, we'll go down 1 and over 3. Again, 1/3, but this time negative. So we can write both asymptotes as plus or minus 1/3. Now we have enough to actually draw the hyperbola. So going back to each vertex, I'm going to draw each branch of the hyperbola coming out of the vertex and getting closer to the asymptote. So there's the right branch, and the left branch will do the same thing. The last thing to do is to identify the two foci. Now the two foci have to happen inside of the curves, and they have to be c units away from the center. With a hyperbola, c squared is equal to a squared plus b squared, those two denominators. So c squared is going to equal 9 plus 1, which is 10, making c equal to square root of 10. Since the two foci are to the left and to the right of the center, we're going to start at the center, 0, 0, and add and subtract that square root of 10 from the x coordinate. So 0 plus or minus the square root of 10, 0. And that's a really good graph of the hyperbola. This time, since our numerators are x plus 2 and y, our x coordinate will be negative 2 and our y coordinate will be 0. So I'll plot that point as negative 2, 0, and that's where the center will be. Next, to find the vertices, since the x fraction comes first, we're going to move in the x direction. So we take the square root of the denominator, square root of 16 is 4, and go 4 units in the x direction. 1, 2, 3, 4. That's where the first vertex will be. Going back to the center, we'll move to the left 4 units. 1, 2, 3, 4. And that's where the second vertex will be. These two vertices happen at, the one on the right is positive 2, 0. And the one on the left happens at negative 6, 0. Using the second fraction, we'll create our box. Since it's y squared over 4, we're going to take the square root of the denominator and get 2. Move 2 units in the y direction. 1, 2. And 1, 2. Now, these aren't really points, but they do give us the boundaries of our box. It's the diagonals of this box that will give us the asymptotes of our hyperbola. So we go back to the vertices and create our hyperbola by making each branch get closer to each asymptote. On the right and on the left. Now we have to label those asymptotes and then find the vertices. Those asymptotes both go through the center. So I'll go y minus the y coordinate of the center, which is 0, is equal to plus or minus the slope times x minus the x coordinate, so x minus -2. Now we have to identify the rise and run, so going back to my box, we see that we rise 2 and run 4. That means our slope is 2 over 4. Of course, we can simplify that to y equals plus or minus 1/2 times x plus 2. Finally, the foci. We're going to calculate the distance by using c squared is equal to a squared plus b squared, those two denominators, and that's 20. So c is the square root of 20, which is 2 square root of 5. Our two foci have to happen inside of the curves, inside of each branch of our hyperbola. And since those two foci are going to be to the left and the right of the center, we're going to start at the center, -2, 0, and add and subtract this 2 square root of 5 to the x coordinate. Before we get started on this last one, there's a couple things I want to point out. First of all, we notice that the x term does not come first this time. The x and the y are switched around. That's going to change the direction that this hyperbola opens. So instead of opening horizontally, it'll open vertically. The other thing I want to point out is that these denominators are now the same. There was nothing that said one of them had to be bigger than the other. So let's see how that affects everything. First, again, we'll find the center. Since the x term says x minus 2, the x coordinate is positive 2. And the y coordinate, since it says y plus 1, is -1. So I'm going to plot 2, -1, and label it as my center. Next, we'll find the vertices. So going back to the first fraction, we again recognize that y is first, so we'll move in the y direction. And we take the square root of the denominator. Square root of 9 is 3, so we'll move 3 in the y direction. 1, 2, 3. And there's our first vertex. And we'll go down 3, 1, 2, 3, for our second vertex. To finish our box, we're going to need to move in the x direction 3 units as well. So 1, 2, 3. That's where this edge of the box will be, and 1, 2, 3. That's where the left edge will be. Once we create our box, we have our diagonals as our asymptotes. And we can come up with a very good graph. Going back to the vertices, draw each branch getting closer to each asymptote. But we forgot to label everything. So just looking at our graph, we see this top vertex is at the point 2, 2. And looking at the one at the bottom, it has the same x coordinate 2, but we went down 3, so that's at -4. The asymptotes, both asymptotes run through the center, so that will be the point I use. Y plus 1 is equal to plus or minus the slope times x minus 2. And going back to my box, rise over run, we can see that we rose 3 and we ran 3. So that would be my slope. And when we simplify things, we'll have y plus 1 is equal to plus or minus 1 times x minus 2. The last thing to do is to identify the two foci. So first we'll calculate what c is. C squared is a squared plus b squared, the two denominators. That's going to make 18, making c the square root of 18. And simplifying that, we'll get 3 square root of 2. Now remember, the two foci have to happen inside of the curves, and that is up and down from the center. So we're going to start with the center, 2, -1, and then add and subtract our square root of 18 to the y coordinate. And that's everything for the hyperbolas.